Alright, so now let's look at the same thing, but this time with friction. Friction depends on normal force, and normal force is not equal to mg. Right, so don't get into that habit of normal force equals mg, so then mu times the normal force must be mu times mg. That's not the equation, right? Again, the boy pulls with 100 newtons, angled at 37 degrees. Mass is total is 10 kilograms, but now there's kinetic friction with a coefficient of friction of 0.5 between the sled and the ground. Let's find the acceleration. So we're dealing with friction. Friction is a force, so we need to start with a free body diagram. Free body diagram, there we go. Easy one, the weight, then we have the tension force at 37 degrees, and then we have our tiny little normal force. Now we also have force of friction pulling to the left. Next, let's remember to put in the acceleration vector, which in our case, we know we're going to be going to the right. So we'll do that in just a second. Because the normal force is less than mg, the friction force is not mu mg. Kinetic friction force is still mu times Fn, but the normal force is not the same as mg. There's our little acceleration vector going to the right. Now any force that is neither perpendicular nor parallel to acceleration needs to be made into components. Weight is perpendicular, so it's good. We have the normal force, perpendicular, we're good. Friction is parallel, so we're good. Tension is neither parallel nor perpendicular to acceleration, so we need to break that one into components. This means we need to make tension into components, one parallel and one perpendicular. So here we are again, parallel to acceleration and perpendicular to acceleration. Cosine because this is the adjacent side, ca, and then sine because this is the opposite side of this right triangle. So as you can see, whenever we make components that are parallel and perpendicular to acceleration, we wind up with a right triangle. And we love right triangles because we know hypotenuse, adjacent, and opposite side. And then we also can use SOHCAHTOA to figure out the magnitude of each one of these sides. We have our balanced force equation. Force is perpendicular, should balance, right? These guys aren't sinking into the snow and they're not floating, so the perpendicular to acceleration should balance. We have a normal and Ft sine theta added together to equal mg. Going down, we have 2 boxes up here, 3 boxes up here, 5 boxes down there. So we get Fn plus Ft sine theta equals mg. The net force equation. Forces parallel to acceleration are going to make ma. Forces against acceleration will count as negative. Stuff that makes it go minus stuff holds it back. So the stuff that makes it go is going to be Ft cosine theta, and the stuff holding it minus the stuff holding it back, frictional force, equals mass times acceleration. Before we can solve for acceleration, we need friction. To get friction, we need the normal force. So we're going to solve the balanced force equation to get the normal force. Again, the boy pulls with 100 newtons. Oh yeah. So we're looking at the balanced force equation, Fn plus Ft sine theta equals mg. And we're trying to solve for that normal force. So we get Fn equals 40 newtons. Now we can go back and solve for the frictional force using the coefficient of friction, which was given to us to be 0.5. Multiply that by 40, and we get the frictional force equals 20. Now we're going to go back to that first equation. If you're not writing this down, go back. Restart this video. Write all of this stuff down. Get in this habit of saying, okay, I have this stuff and I have this stuff. Just like with projectile motion. Sometimes you need to go back and forth between the y motion and the x motion. We use the y motion to find time, and then we use that time for the x motion in parabolic motion. But for forces, we have parallel and perpendicular. Sometimes we need to look at the perpendicular to get something, and then we're going to go use it in the parallel. stuff that makes it go minus stuff that holds it back equals mass times acceleration. We know now what the frictional force is. And we know Ft is 100 cosine of theta equals 0.8. So dividing by 10 from each side, we get the acceleration to be 6 meters per second squared. That's it for that one.